The stereoisomers are related to one another as a non-superimposable mirror images. They are said to be enantiomers. Acylation means acyl group will be get introduced to the benzene ring, whereas the alkylation means alkyl group will be get introduced to the benzene ring. If it is asked for 3 marks, remember they are definitely going to ask with the SN1 mechanism, because there are 2 steps will be there to write the mechanism. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, welcome back to the revision class. In this session, we are going to discuss with the Unit 10, Haloalkanes and Haloarenes. Before going to discuss with this unit, let's see the weightage of this unit. By this unit, we can expect the 1 mark question, 1 2 mark question and 1 5 mark question, and the question numbers will be goes like this. The question number 11, question number 22 from the part B, and question number 42 will come from this unit, and totally we can expect the 8 marks by this unit. And you can see that this is a Group 3 Organic Chemistry first unit, the Haloalkanes and Haloarenes. All the organic chapters questions will comes in the part D, that is in the 5th main. So, the 5th main is meant for only the organic chemistry questions. Okay. So, the first question 42 is come from the Haloalkanes and Haloarenes. Okay. So, let's see how the 1 mark, 2 mark and 3 mark questions will be asked. Why it is 3 marks? Because the 5 mark question will be split into 3 plus 2. Sometime it will be split into 2 plus 2 plus 1 also. That is why I have added the 3 mark question directly. We'll see how the 1 mark question will be raised. Okay. What are enantiomers? Enantiomers are nothing but a non-superimposable mirror images. So, the stereoisomers are related to one another as a non-superimposable mirror images. They are said to be enantiomers. In the exam, you need to specify the word non-superimposable mirror images, thereby indicates the enantiomers. Okay. Next question, what is chirality? Or you can say chirals also. The object which are non-superimposable on their mirror images are said to be chirals. Okay. Next question, what is racemization? The process of conversion of enantiomers into racemic mixtures. We call it as what? Racemization, and it is a process we are converting the enantiomers into the racemic mixtures. Hence, it is named as racemization. Next question, expand DDT. So, DDT is nothing but a dichloro, diphenyl, trichloroethane. Okay. Next question, what is phosgene? Phosgene is an oxidized form of the chloroform. Okay. Next question, CH3Br plus AgF giving rise to CH3F plus AgBr. Name the reaction. So, most of the time, by giving a reaction, you need to name the name of that named reaction, because of the organic chemistry, most of the reactions are meant for naming. Hence, it is also named as named reactions also. So, here you can see that there is a exchange of the halogens which is taking place between the alkyl group. Hence, it is a Schwarz reaction. Next question, it is most frequently asked, what are freons? Freons are the chlorofluorocarbons of methane and ethane. So, the chlorofluoro forms of ethane as well as with the methane are said to be freons. Name the organic product which is formed when dichlorobenzene is treated with sodium in dry ether. So, you need to mention the product. We know that product is nothing but a diphenyl. Coming into the next question, the Rx plus NaI in presence of dry acetone giving rise to the Ri and NaX. What is the name of this reaction? So, here again, so R and X, that is the alkyl halide which is allowed to react with the sodium iodide in presence of dry acetone. In presence of what? Dry acetone, what does it happen? So the R and I alkyl iodide will be formed with the formation of sodium halide. So this is a Finkelstein reaction. Name the compound which is formed when 2-bromopropane is heated with a alcoholic potash. When 2-bromopropane which has been heated with alcoholic potash, we know that the product propene is formed. Okay. So be focused with a direct question like enantiomers, racemic mixtures or freons like that, and also be cautious with the named reactions which has been asked repeatedly in the organic chemistry. Now, let's see with the 2-mark questions now. Okay. Explain the Finkelstein reaction with an equation. So, the Finkelstein reactions are nothing but reactions of alkyl halide with the sodium iodide to give a alkyl iodide with the formation of sodium halide. So, alkyl iodide are prepared by the reaction of alkyl chlorides or with the bromides in the dry acetone. It is said to be Finkelstein reaction. This is a general reaction. You can take one example for this. So, I'll go with the R as a CH3Cl. This is an alkyl chloride which is allowed to react with the sodium iodide. So, what will happen? So, alkyl iodide with the sodium chloride will be formed. So, this is known as what? Finkelstein reaction. So, because in organic chemistry, please learn to write the general reaction. So, it is very easy to go with the examples. Okay. Next question. Explain Schwartz reaction with an equation. Alkyl fluorides are prepared by heating the alkyl chloride or bromide in presence of metallic fluoride such as the silver fluoride or mercury fluoride, cobalt fluoride and tin fluoride, etc. And the reactions are said to be Schwartz reactions. So, any alkyl bromide or alkyl chloride can be prepared by using what? Metallic fluorides. So, it forms what? RF, that is the alkyl fluorides will be obtained. So, these two can be a general reaction. I have taken out the alkyl bromide and alkyl chloride to show that reaction. Now, you can go with an example by considering CH3Br, R as a CH3 which is allowed to react with AgF. So, it gives us to the CH3F plus AgBr. So, this is a alkyl fluorides. Okay. So, it is a methyl fluoride. Next question. Explain Fittig reaction with an equation. So, when aryl halides are heated with the sodium in a dry ether, two aryl groups are joined together to give a biphenyl. So, aryl halides means what? We know that alkyl group means what? We can show the aryl halides by writing the benzene ring with removing the hydrogen by adding with the halogen. Hence, it become what? Aryl halides. So, which is allowed to react with what? Sodium metal. So, I am taking what? 2 aryl halide which is allowed to react with a sodium metal in presence of dry ether. So, how many aryl halides I have taken? 2 molecules of aryl halides. So, the halides will be react with sodium to form 2 NaX, or you can take Cl also. Okay. So, you will get biphenyl. You will get a biphenyl. So, in the examination, if you don't write this bond, again you will lose the marks. By showing that 2 benzene rings are joined, to show that biphenyls which is formed, it is very, very important to write the bond between the 2 benzene ring and to show the biphenyls. Next, explain Woods-Fittig reaction with an equation. So, either Woods reaction can also be asked because already you have studied the Woods reactions in your first PUC. So, please go through with that and get prepared with a wood splitting also. When a mixture of alkyl halides or aryl halides which has been heated with the sodium in dry ether medium, alkyl benzene will be formed. So here I have taken out the aryl halides and alkyl halide which is allowed to react with the sodium metal in presence of dry ether. What will happen? The aryl halides and alkyl halides will react themselves and the sodium will carry this halogen atom. Thereby, it forms a sodium halide and R group. That is the alkyl group will be get substituted to the benzene ring and thereby it gives a benzene substituted alkyl group. It is nothing but a alkyl arenes. That's said to be what? Alkyl arenes. You can take one example. So, bromobenzene react with the sodium metal in presence of allowed to react with the haloalkanes known as methyl bromide in presence of dry ether. Again the sodium will carry this halogen and forms a NABR and also this alkyl group will be goes and substituted to the benzene ring. Thereby it forms a alkyl arene. Here the name of this compound is toluene. Next question. Explain Friedel-Crafts acylation reaction with an equation. So both the alkylation and acylations are too important, but most of the time they have asked the acylation reaction. That is why I have put this question. When chlorobenzene which has been heated with the acyl chloride in presence of anhydrous aluminium chloride as a catalyst with a mixture of ortho and a para, chloroacetophenones will be formed. Okay, so maybe this question can also be asked as a direct question. Sometime by giving this reaction you need to write the end product also. So please go through with the alkylation and acylation. Acylation means acyl group will be get introduced to the benzene ring, whereas the alkylation means alkyl group will be get introduced to the benzene ring. So here we are taking what? Chlorobenzene which is allowed to react with the acyl group, that is a acetyl chloride we have taken. So what will happen? This is a acyl group. In presence of anhydrous aluminium chloride, this acyl group will be goes and substitute to the benzene ring. Thereby it forms a ortho as well as the para substituted chloroacetophenone will be formed. So they can ask you to write the end product. So how the end product will be formed, that is ortho and the para substituted, and it is very important too. Okay. Explain the Sand-Meyers reaction with an equation. So, when a primary aromatic amine dissolved or suspended in a cooled aqueous mineral acids, it is treated with the sodium nitrate or diazonium will be formed. The mixing of freshly prepared diazonium salts with a cuprous chloride or with a cuprous bromide results in a replacement of the diazonium group by chloro or with a bromo. So this is a Sand-Meyers reaction where you are taking the primary amine which is allowed to react with the sodium nitrate in presence of halogen acids at very small temperature. It gives us to the diazonium salts. The same reactions you are going to study in your amines chapter also. Okay, be careful with that. Next, the 3-mark question. We know that from the haloalkanes and haloarenes, the 3-mark question is nothing but a SN1 mechanism and SN2 mechanism. So if it is asked for 3-mark, remember they are definitely going to ask with the SN1 mechanism because there are 2 steps will be there to write the mechanism. If it is asked for 2 marks, you need to go with the SN2. Because SN2 has a single step mechanism. So there is no need of writing with a 2-step there. So they'll ask only for 2 mark, but SN1 will be definitely asked for 3 mark. Okay. Be careful while attending the questions. Okay. SN1 mechanism is, it is a substitution nucleophilic unimolecular first order reactions, and reactions will be follows like this. So first thing is you need to write the general reactions where tertiary butyl bromide which is allowed to react with KOH to form tertiary butyl alcohol. To form what? Tertiary butyl alcohol with the formation of KBr. For this reactions, you need to write the mechanism for this. The first step is a haloalkanes undergo slow ionization to form a carbocation. So the first step is the tertiary butyl bromide. So they will mention in the question also, by taking what? Tertiary butyl bromide only, you need to write this mechanism. Okay. So the tertiary butyl bromide in the first step will undergo slow ionization. Thereby it removes its halogen group and get the positive charge. So since it is developing the carbocations, this is a tertiary carbocation. Hence this step, which is known as a formation of carbocation with the release of halide ion. In the second step, this tertiary carbocation will be attracted towards the nucleophile, that is OH. Thereby, it loses its positive charge and get attracted towards the OH minus ion and forms a tertiary butyl alcohol. It forms what? Tertiary butyl alcohol. So this is very, very important to know that the tertiary butyl alcohols will be formed from the tertiary butyl bromide, and you need to write the second and the first step. Remember, the second step is the attack of the nucleophile. Okay, you need to mention it. First step is the formation of carbocation. Second step is the attack of nucleophile, and you need to write the correct equation to get the 3 marks. And lastly, you need to write the order of that reactions. Since we know that rate is directly proportional to what? Alkyl halides in this above equation, and we know that the first step itself is the slowest step and it is a rate determining step. Hence the order of the reaction is 1 in this case. So at the last, you need to write the order of that reaction by understanding the rate of this reaction. So the 3 things you need to remember is, one thing you need to write the general reaction, and the one is mechanism you need to properly have to write. If you forgot the general reaction, it's okay. Go with the reaction mechanism and write the order. Okay, if it is asked for the SN1, similarly in the SN2 also. Explain SN2 mechanism for the conversion of methyl chloride to methyl alcohol. So this is a general reaction, I have put it here. So methyl chloride allowed to react with the KOH to form a methyl alcohol with a KCl. So what will happen? We know that this is a methyl chloride. So it will be get attracted towards the nucleophile. So thereby it attacks the nucleophile, which always comes and attacks in the opposite direction. Why it comes and attacks from the nucleophile? The bond between the carbon to chlorine is very strong as that of from the carbon to hydrogen. That is why the nucleophile which comes and attacks from the backside of the methyl chloride, thereby it creates a transition state. So this is a intermediate step. After this, it will cleave its halogen group, thereby it forms a methyl alcohol with the release of halogen. So again, for this step, if you know that the rate of the reactions which is depend both upon the nucleophile as well as with the alkyl halide, hence the order of the reaction is 2. Okay, so that is the one thing that you need to keep it in a mind while writing the mechanism. And you need to show that our nucleophile is going to attack from the backside to the methyl chloride. Hope you understood with this unit. I'll come back with the next unit. Till that, take care, be safe. Thank you.